Okay, good morning. Welcome to
Remember 1007.
FamilyMath 1007. Sorry about my little cough today. We did the dice problem the other day. So you roll till first 6. 6, but ignore all rolls
That are odd numbers.
with odd numbers. Okay. So you're trying to roll a dice until you get a 6, but every time you get an odd number, you have to start over.
Yeah.
So it doesn't count. So that would be my first roll. Okay, look at that. I did it in 2. And then, do you remember what the expected number of rolls was?
I think it was 1.5.
Rolls is 1.5. And why is this a surprise?
Well, it's very close to the same problem. Just rolling maybe a 3 on a 3-sided die.
Yeah,
And that would take.
it seems like it's asking you to roll a 3-sided die with sides showing 2, 4, and 6, but it's actually turns out to be a different problem. And I saw on a blog post about this problem, actually the blog post where I learned about it, a really interesting way to think about this problem. So when we did our, we're going to think about the problem in the way the blog post suggests, and actually do the calculation.
Okay.
Okay. So, sorry about that. When we did our computer program, we basically said you roll, so start rolling. Let that start rolling. And odd number, go back to the beginning. 2 or 4, you keep going. And then a 6, you're done, and you can just go on to the next trial.
Okay.
Right. We didn't draw it out this clearly, but we did notice that in the program we wrote, anytime you get an odd number, start over. Anytime you get a 6, start over. So the blog post says reformulate the question to be roll until you get something different, not equal to 2 or 4. So it's basically saying that the 6 and the odd numbers are doing the same thing in all your trials. So the question is reformulated, which is basically saying roll until you get something other than a 2 or 4, because anytime you get a 2 or 4, what happens?
You keep going.
And anytime you get something not equal to 2 or 4?
You make a new trial.
Or no, you go back to the start.
You go back
You
to
don't
the start.
necessarily make a new trial.
No, it is a new trial, because the odd numbers don't count and the 6 ends your trial.
Yeah.
Right? So it says that basically in this process that we're doing, there's nothing special about 6, because the same thing that happens to 6 happens to 1, 3, and 5. So we should treat them the same.
Okay.
Does that make sense to you, or is that confusing?
That makes sense.
But the only thing is that the 6 gives you a success. It ups your success counter by 1, but the 1, 3, and 5 don't.
That's right. Do you think it would be different if I move, say, the 5 down here?
Well, no, because it would still be 1 out of a set of 4.
Okay. So in some sense, the 1, 3, 5, and 6 are all playing the same role here. And since they're all equally likely, we'll just pretend that they're all the same, because they're all sending us back to the beginning.
So every time you roll 1, you get a success.
Yeah. It's a very clever idea. But this makes it really easy to figure out the probabilities. Because what's my chance on roll 1 of sort of winning now? Getting something other than a 2 or 4?
It's would be 2/3.
That's right.
And then every time it's
What's my chance of getting that first non-2 or 4 on roll 2?
the same number or just another non-2 or 4.
Another non-2 or 4 for the first time on roll 2.
So it'd be 1/3 times 2/3.
Mhm.
How about on roll 3?
1/3 times 1/3 times 2/3.
Yeah.
So devote yourself a geometric series.
I won't write it out all the way, but yep. So we get 2/3 times 1 plus 1/3 plus 1/3 squared plus 1/3 cubed. Now this should equal 1, right? Because I have to add, I have to get a non-2 or 6 or non-2 or 4 at some point. And the series that we're trying to add up to get the expected number of rolls is 2/3 1 times 1 plus 1/3 times 2 plus 1/3 squared times 3 plus 1/3 cubed times 4. This gives us the expected number of rolls. So we need to figure out how to sum this series.
Okay.
Okay, so we'll do that in the next video.